session. Decisions will be only two commissioners in the room today. That's Commissioner Martinez and myself. Commissioner Lim Tiako will be tuning in over the live stream. And Commissioner Sanchez is running a little late, but he's going to be tuning in on live stream on his way in. So, and this meeting, and this presentation will also be carried live on YouTube and also will be on our website once we're finished. Okay?
Okay, thank you, Mr. Chairman. I have with me today Dr. John Jensen from UOG's Water and Environmental Research Institute. We're presenting this morning on the One Guam Water Resources Information Program. This presentation describes the proposed program, which is also known as OGRIP, and which is envisioned to fulfill the objectives of the December 2016 One Guam Water MOU between the CCU, Joint and Region Marianas, GWA, and NAVFAC Marianas for collaborative and coordinated management of our island's freshwater resources. Specifically, we will describe and explain the composition, objectives, products and services, and funding structure of the collaborative integrated program. I will start with a brief summary of the history behind our current water resources data collection system. We will review the existing programs for data collection both on the civilian and the military side, and how Guam's local programs dovetail with nationwide cooperative programs between the U.S. Geological Survey, or USGS, and state and territorial water resource agencies. We'll highlight the work underway now, led by GWA, to rehabilitate the civilian data collection program and to expand the military program into areas inside the DoD fence line. And we will then review the framework that was established by the 2016 One Guam MOU between the CCU, JRM, GWA, and NAVFAC, and how OGRIP fits into that framework. And we'll then examine the mission of the One Guam Water Resources Information Program and the services and products that WERI and USGS will provide through that program. And we'll conclude by describing how the program is to be structured, administered, and the big point, how it's to be funded. So the central purpose of OGRIP is to provide answers to basic questions that everyone asks about the water supply. Questions such as these: how much fresh water is available and where can we obtain it? How safe is the aquifer from saltwater intrusion? And is it happening, and where and why is it happening? How much water can be sustainably pumped from a given well or well field, or obtained from a stream or a reservoir? And what are our best options for development of new water resources? So to answer these types of questions, of course, you need to start with data, good data, and the more the better. So we'll start with a brief history of water resources data collection on Guam. And for that, I'm going to turn the podium over to one of the guys who makes his living from Guam's water resources data and has been part of its history for the past 28 years, Dr. Jensen.
Thanks, Miguel. Well, water resources data collection on Guam began in 1951 when the Fena Dam was completed, and USGS was brought on to monitor the reservoir stage, and they've been providing service to the Navy ever since. Most of our groundwater observation wells are the legacy of the 1982 Northern Guam Lens study that was led by the legendary hydrogeologist John Mink. They put in place an extensive system which is still with us today, but by 1998, the 1982 system was no longer being funded, and I'll say more about that later. In 1998, the 24th Guam Legislature rescued the program, which has now acquired more than 2 decades of continuous, extensive, and systematic data collection. Good, high-quality data. And the next major event was the installation of 11 exploratory wells that were pump tested and gave us data across the aquifer for evaluating the potential of additional development by putting new wells into these areas. This year, the monitoring system expansion and rehabilitation project, which is funded by a $3.7 million grant to GWA, is refurbishing the original 1982 wells again, and will add new observation wells to the military installations. And you'll hear more about that in a few minutes too. So that's the basic history. It was during the epic El Nino drought of 97-98 that the 24th legislature unanimously passed two bipartisan bills that established our existing programs for water resource data collection and application. And at that time, our water resources were a matter of deep and widespread concern. The Fenna Reservoir, as you'll recall, was at a record low level. The Navy was rationing water to its own customers and had none to sell to GWA. And rumors were going around that the island's groundwater was getting saltier as the freshwater lens thinned from the drought. And I still vividly recall taking a call in my office one afternoon from a staff member at Senator Joanne Brown's office. And she wanted to know if the rumors were true and if Weary had any data to confirm one way or the other whether our water was getting salty. And I explained that unfortunately we had no data. And so we had no way of knowing or giving him any advice one way or the other. The data collection program had been shut down for lack of funding, was in disrepair, and there was no prospect for rehabilitation. So Senator Brown called me a few minutes later and asked, what would we need to do to restore the data collection program? And as they say, the rest is history. The first response was Public Law 24-161 in April of '98, introduced by Senators Joanne Brown, Tom Atta, and Frank Uggan, and enacted with a unanimous vote. It created a civilian drought management and water conservation plan to complement the military's, and it established what was named in the legislation and still is called today the Comprehensive Water Monitoring Program, or CWMP. And they did this by refurbishing the 1982 hydrologic data collection infrastructure and restoring regular and systematic data collection administered by WERI in partnership with USGS. So WERI receives an annual allotment from the legislature specifically to retain USGS services as part of a national program, which I'll say more about in a minute or two. And this national program has USGS working in partnership with all of the state and regional state and territorial agencies to collect standardized data. So over the 23 years since the legislature instituted the CWMP, the USGS Pacific Islands Water Science Center in Honolulu has dispatched a field team every quarter that comes out and accompanied by WERI personnel, students, and student research assistants collect the data that goes into their national database and into our local database. The local database began with the legislation in August '98 when the legislature followed up on its restoration of the data collection program and enacted Public Law 24-247, which was introduced by Senators Joanne Brown, Tom Atta, and Tony Blas to create what they called the Guam Hydrologic Survey, or GHS program. GHS gives WERI a funded mandate to archive the data that comes out of the CWMP and other water resource data on Guam that's collected by other agencies. We're also mandated to maintain a publicly accessible database, analyze and apply the data, and report on conditions and trends in the aquifer, and conduct research to support effective management of Guam's water resources. The GHS mandate specifically includes providing the island's water resources managers and policymakers with timely and reliable expert advice, and providing training and outreach to the island's water resource professionals, educators, and citizens. Among the primary users of GHS products and services, arguably the primary user is, of course, GWA, which was established only a couple of years before CWMP and the GHS programs by the 23rd Guam legislature, which also included Senator Santos at the time. For the story of GWA's origin, I'm going to give the podium back to the GWA General Manager.
So as Dr. Jensen described, the 23rd Guam legislature enacted legislation that created GWA with the purpose of getting the utility to operate like a business enterprise. Many of the senators from the 23rd legislature have helped GWA over the years to achieve the vision of a utility dedicated to water and wastewater services in order to enhance growth and development. The bill that became Public Law 23-119 was introduced by Senators Tony Lamarena, Tom Atta, and Mark Forbes. Commissioner Santos, who was in that class of the legislature, and former Senator Atta as the longtime oversight chair, have helped to advance GWA's stewardship of our island's water resources. And that history of responsible policymaking with respect to water resources is aligned with the subject discussed in this presentation. So that's how we got where we are today. We've come a long way, and as the chairman fondly points out, we still have a long way to go to get better. But before we look at the improvements that are underway now, we will review the existing programs for data collection, both civilian and military, and how Guam's local programs dovetail with the nationwide cooperative programs between the USGS and state and territorial water resources research institutes, and the role that WERI and USGS partnership has played in getting us to where we are. So I'm going to turn it back over to Dr. Jensen to go through that.
So let's start by identifying the three kinds of data that we collect. We measure rainfall across the whole island with judiciously spaced and placed rain gauges. And in the north, we measure the levels of the top and bottom of the freshwater lens, so we know how thick it is. And in the south, we measure the levels or stages and velocities of selected streams. So we've got rain gauges, stream gauges, and water wells that measure levels and depth of the lens. Our data collection program on Guam is the comprehensive water monitoring program put in place by the 1998 legislation. The CWMP is part of a jointly funded national program administered by the Geological Survey. And under the CWMP, the USGS sends field teams quarterly, as I mentioned, to download the data and service the instruments that are installed on these stations across the island: rainfall, stream flow, and groundwater. And these data are entered into the USGS national database and the local GHS database that WERI maintains. And here are the field stations of the Comprehensive Water Monitoring Program. As you can see, there are 6 rain gauges covering both the north and south, the yellow squares, and 3 stream gauges in the south, and 14 observation wells in the north. For a bit of perspective, when we get to the budget section of the presentation, you're going to see that the data collection program accounts for 2/3 of the overall budget for the entire One Guam Water Resources Information Program. The other third is what we do with the data management, analysis, research, and reporting, and all those other services only use 1/3 of the funds. 2/3 of the investment is in gaining the data in the first place. And as you know, we get 90% of our drinking water from the northern aquifer, so most of our investment in data collection is in collecting groundwater data, and that's evident from the map. So it should not be surprising that the groundwater data collection constitutes about 2/3 of the total data collection effort, or about 45% of the total program cost. So most of the other 10% of the island's drinking water comes from the Navy's Penner Reservoir. And in a separate data collection program for the Navy, the USGS collects rainfall at 2 rain gauges that straddle the watershed from the east and west, and 3 stream flow gauges, 1 on each of the 3 rivers that feed the reservoir. The reservoir is monitored continually by the spillway gauge that they installed in 1951. And USGS also conducts an annual survey of dam settlement and prepares an annual report for them. So as I mentioned, Guam's local data collection program dovetails with the nationwide cooperative programs that are depicted here between USGS's state water science centers and their local, state, and territorial partner agencies. They're funded through 4 nationwide programs, and funds from the first 3 contribute to what they call the Cooperative Matching Funds program. And these are funds that are used to cost share with each of the local partner agencies. Guam's local cooperative data collection program, the Guam Comprehensive Water Monitoring Program, over its 23-year history has contributed about 60%, and the USGS has contributed about 40% of the total. It varies from year to year. The 4th program is established under the Water Resources Research Act program, which created the Water Resource Research Institutes at each land-grant university and funds them. They receive some federal funding through the USGS to do local work. And on Guam, that's us at WERI, the Water Resources Research Institute, which under this national charter partners with USGS to not only, in this case, collect data for us, but to work with us on research projects and partner with us in using the data. So that partnership leverages our local knowledge with their national resources. Our knowledge of Guam's resources goes back 50 years ago to the establishment of WERI at UOG in 1975. And our formal partnership, funded partnership with USGS now goes back to 1998 when the legislative reforms launched the partnership. The collective depth and breadth of the local and regional knowledge leveraged with continuous access to national scientific resources enables the WERI USGS team to provide continuity of services, accessibility and accountability, and reliable advice and recommendations that cannot be matched by one-time studies done by occasional changing separate entities based in headquarters outside of Guam. So before I give the podium back to Miguel to describe the ongoing rehabilitation and expansion of the data collection programs, I'd like to highlight some of the notable achievements of the WERI Pacific Island Water Science Center partnership. You may recall, as we mentioned earlier, in 2010, the U.S. Marine Corps invested $1.2 million in a 3-year modeling study led by USGS in partnership with WERI. And NAVFAC retained ACOM Technical Services to manage an exploratory drilling program in which 11 wells were drilled. WERI collaborated on both of these projects. And for the modeling study, we built and applied a 3-dimensional numerical groundwater model to examine the likely effects of expected increases in pumping and possible natural stresses on the aquifer, such as an El Nino-induced drought, like the 1998 drought. Besides the model, the outcomes of the project included an expansion of our aquifer database, a more detailed and accurate state-of-the-art map of the aquifer, and new assessments of aquifer recharge and aquifer responses to pumping. These are invaluable tools that guide exploration and development. The model provided a tool to estimate how current production with the existing system is likely to be affected by natural stresses and how water quality might be affected by changes in pumping at the existing wells. However, to know for sure how the aquifer actually responds to natural stresses and changes in pumping, and thus to be able to evaluate the model itself, we need data on its responses. Specifically, we need to see the changes in water levels in wells and changes in salinity of the groundwater in response to droughts, in response to pumping. And models are not a substitute for data. In fact, they require data, lots of data, to build, calibrate, validate, and periodically update. So in 2014, after the modeling and exploratory drilling projects were complete and we had delivered the reports, U.S. hydrologist Steve Gingrich, who had led the modeling study, and Todd Presley, who is tuned in to us now, and who leads the data collection activities on Guam and has for many years now, along with myself and Dr. Nate Urbana, who's WERI's other groundwater specialist, prepared a proposal to DOD for another rehabilitation of the existing system and expansion of the aquifer monitoring system into the undeveloped parts of the aquifer that we had identified as prospective locations for new well fields to support the build-out. One Saturday morning, Nate and I sat in the lab at WERI on the phone with Steve and Todd in Hawaii and picked out the 8 areas shown on the map by the red ovals there, where we recommended that new deep observation wells be placed. A deep observation well is one that extends all the way through the lens from the top of the water table to the salt water beneath it. And the installation of this suite of wells would give us full coverage of the aquifer, not only the places that are well developed that need closer monitoring, but also the places that are undeveloped and are the obvious ones to develop next. And you'll hear more about that in a minute. And fortunately, and a bit to our surprise, the 2014 WERI USGS proposal was funded 2 years later by DOD's Office of Economic Adjustment and was incorporated into the One Guam Water Framework that was set up in 2016 with the MOU between CCU, Joint Region Marianas, GWA, and NAFAC-MAR, in which the agreement was made to formally integrate, rehabilitate, and expand the data collection program and establish programs for ongoing expert scientific and technical advice from both WERI and USGS to GWA and NAFAC-MAR, so that the resource could be jointly managed. Work is now underway to rehabilitate the civilian data collection program and expand the data collection program in military installations, which will give us a high-quality, continuous record of the entire aquifer. Since GWA received the grant and has oversight on the contract, I'm going to hand the mic back to GWA to cover the rehab expansion program and the launching of the One Guam Water Framework.
So as the commissioners are aware, starting in 2016 and through 2018, GWA was awarded $173 million in grants by the Department of Defense to provide for water and wastewater infrastructure improvements to support the military buildup on Guam. A key element of these improvements is the rehabilitation and expansion of the Northern Guam Lens monitoring system. And this is needed to ensure that planned increases in the withdrawal of Guam's shared sole source aquifer would be properly planned, developed, and managed. The Monitoring System Expansion and Rehabilitation Project, or MSERP as it's known amongst us, was funded with $3.7 million and includes the installation of 7 new deep monitoring wells and the rehabilitation of 12 of the existing wells that Dr. Jensen described previously. This federal funding comes with an obligation that GWA, as the grant recipient, will protect the investment in these assets and provide for their long-term maintenance and sustainment, and thereby ensure that the kind of gap-free continuous records that our hydrologists rely on, as Dr. Jensen just now explained. So this long-term maintenance and sustainment is aligned with the provisions of the One Guam Water MOU that was signed in 2016. As part of that cooperation, GWA and NAVFAC have agreed to sharing in the long-term maintenance based on well locations, whether outside the fence line or inside the fence line, respectively. That MOU also provides for implementing cooperative data collection and sharing across the aquifer as a means to effectively and responsibly manage the water resource. These maps show the locations of the rehabilitation and the expansion phases of the MSERP program. The 12 CWMP wells, 10 of which are on civilian land and 2 of which are on DOD property, those 12 wells that are being refurbished are shown by the blue dots on the Google Earth image on the left-hand side, and by the black dots on the map of the aquifer basins on the right-hand side. And you can see that the 7 new wells are inside the military installations, and those are candidates for the new groundwater production well fields by either Navy or the Air Force. And those are shown by the pink balloons on the satellite image on the left and the red squares on the aquifer basin on the right. And so you'll see that on the top right-hand portion of the map on the right, there are 4 of those red squares, 4 of those new wells, and those are in areas where we have very little data right now on those subbasins. And so that's one of the reasons why this project for installing the new wells is critically important. So the rehabilitation phase of the project started earlier this year, and we're about 98% complete. We only have some minor punch list items remaining on most of those rehabilitated well sites. The expansion project contractor is currently in the process of securing permits so that he can begin construction on the new wells inside the DOD fence line and take care of the refurbishing the 2 existing wells on DOD property. So the next series of slides just walks us through the existing conditions that are common at most of the sites, and then the before and after of the rehabilitation program at some of these sites. So the example we've chosen here is EX9. It's an existing well located outside of PC Lujan Elementary School. As you can see, the pre-construction condition, the site has been neglected. There's no maintenance of the site. Vegetation has encroached over the fence line. The fence has deteriorated, and so has the cover of the well to protect that direct access into the aquifer. So the scope of work sequence begins on the right-hand side of this slide. Obviously, the first step was to remove the vegetation. And then we chipped the concrete around the wellhead, and you'll see the reason for that on the next slide. After we removed the fence, photo number 4 shows that the well pad was removed. And so in demolishing the well pad, chipping that concrete around the well casing protects it from that demolition activity. On slide 5, you see we excavate around the well casing down a few feet and a few feet in diameter in order to refurbish the surface well casing. Item 6, you can see that refurbishment. We cut the existing casing, provide a coupling and a new well casing that extends several feet above ground. And then we fill in that excavation, and on photo 8, you can see we've framed in where the new pad is going to go and started soil compaction. Once that's done, we test to make sure that the compaction, the appropriate density has been reached, and then we set the fence posts for the new fenced enclosure. And you can see in photos 10 and 11 that being done, along with laying down the initial stages of steel reinforcement on the well pad. Photo 12 on the left shows the completed rebar grid along with all the fence posts set. And then photo 13 shows us pouring the concrete pad. And once that pad has been leveled and provided with this appropriate surface finish and cured sufficiently, then as you see in photo 14, the contractor comes back and completes the fenced enclosure, including an access gate. So for EX9, you can see the before and after, the new pad, the new fenced enclosure, and the new refurbished casing. The only thing that's missing on this photo is an aluminum enclosure that goes over every well casing. So A20 similarly was refurbished. This is located outside of the Ordat Chalapago Elementary School. The grounds are maintained, so there wasn't the same issue here of vegetation overgrowth. And you'll notice that the pad is smaller, as is the final fenced enclosure, which isn't shown here yet. That's because there is no fenced enclosure because this is inside the school property, so it's already fenced in. This is EX1, which is located outside of JQ San Miguel Elementary School in Mangmang. You can see the new fenced enclosure here and the pad and an improved access and drainage actually to make sure that there's no flooding around that well site. This is EX4, located in Tai Manila, or it might be Chalampago actually, but behind Father Duenas and past the Infant of Prague Nursery. Again, this is a full well enclosure. It has been provided. It's not shown in this picture, but it has been installed already. And this is BPM1, which is located behind Santa Teresita Church in Manila. This is one of the sites where we've not completed the pad or the fenced enclosure yet. This is actually property that the Navy is turning over to GWA, and the Navy Real Estate Office is currently working on that transfer. So the in-ground work has been completed, but the pad, the fencing, and the well enclosure are pending resolution of that property issue, and then it'll be completely finished. This is A16, which is located outside of BP Carbolito Elementary School in Barragata, and it's outside the school's fence line, so this site does get its own fenced enclosure, and it also has a aluminum enclosure for the wellhead as well. This is M10A, which is located outside of JM Guerrero Elementary School on Harmon Loop Road. In the after photo on the right here, you can see that the new aluminum enclosure or cabinet that goes over the well casing, and this is to provide access for the instruments that are installed during the data collection deployments of USGS and WERI personnel. This is well EX6, which is located behind the old Dedido Flea Market towards Machechi area on Cueto Road. Again, another smaller site with a smaller enclosure. This is EX10, which is located on Swamp Road, just off of Route 3, north of the Okado High School. And you can see here on the after photo on the right on the bottom, the full aluminum well enclosure that's already been installed. And this is EX7A. EX7 was actually a new well that GWA, Guam EPA, and WERI worked together to get reconstructed when the original well, EX7, was adversely impacted by DPW's Route 1, Route 3 road widening project. DPW's design for that widened road left the original well only a couple feet off of the curb and about a foot below the adjacent ground level, creating a potential flooding hazard and a hazard for maintenance crews as well as the monitoring teams when they have to deploy and back the vehicle up to the well in order to put in the equipment. So after weeks of negotiations, DPW and Federal Highways finally agreed to fund the abandonment of the old well as part of their road widening project and the construction of this replacement well. And that was very early on in the process, but they did use the design that GWA and its consultants had come up with for this new expansion program. So this well was reconstructed in to the same specifications as the new 7 wells that are going in right now. And this slide depicts some of the features of that new well construction. So we will drill boreholes for the new wells in 18-inch diameter all the way down to 40 feet. After that, it'll be a little larger than a 10-foot diameter borehole that goes from the 40-foot depth all the way down to the completed well depth, which depending on location varies between 500 and 780 feet deep. A 6-inch casing will then be installed with the screened portion, the machine slotted Schedule 80 PVC screen portion installed from about 2 feet above the highest water level, highest modeled water level, all the way down to the bottom of the casing. So the placement of these wells are intended to provide data, as I mentioned before, in those basins within the NGLA where we currently have very little data in order to align with where DOD plans to put future new production wells, and that way we can monitor, plan, and properly manage the water resource in those areas. So this is a good place to stop for a break, maybe, if the commission desires. We have some refreshments if you want to do that, or if you prefer, we can keep plugging along. We're about halfway through.
We should keep going. We're good.
Okay.
Yes.
So we will now shift to review the provisions for the One Guam Water Resource Information Program within that 2016 MOU that was signed between the parties. The framework for the cooperation on water utilities between NAVFAC and GWA began actually with the 2010 MOU, which you can see being signed here by then Chairman Sanchez and the GEMCAS John Beneventi. This MOU was intended to provide the mechanism by which utility services could be improved on both sides to address impacts from the planned military buildup. Significantly, the MOU specifically called for cooperation between NAVFAC, GWA, and their respective leadership in ensuring, quote, long-term sustainable management of the NGLA, unquote, and in designating a management advisory structure which included 3 tiers of subject matter experts to accomplish the goals and objectives outlined in that MOU. First, a technical experts group for technical knowledge and guidance. The second tier is a working group among the utility providers and their management. And third, a senior advisory group of Navy leadership, CCU, and legislative leaders for vision and guidance. In December of 2016, GWA, NAVFAC, CCU, and Joint Region Marianas signed the updated One Guam Water Memorandum of Understanding. And the objectives were to maximize the effectiveness of DOD and GWA water utility systems as a whole to provide sustainable, reliable, compliant, and secure water delivery. So I'm going to ask Dr. Jensen to come back up and go through the specific provisions of the MOU that relate to our One Guam Water Resources Information Program.
As Miguel mentioned, the 2016 MOU specifically calls for improving the observation well system by expansion of the current system and rehabilitating the existing system, which is the MSER program that he just described. The MOU also established a commitment to share access to and responsibilities for the maintenance of those wells.
Sorry.
No problem. And another provision of the MOU was the establishment of the technical experts group, as he mentioned, which followed the model in the 2010 MOU, which specifically included WERI and USGS alongside the GWA and NAVFAC-MAR engineering staffs. It provides for this group to share the data and develop and maintain databases and technical tools to monitor and access the health of the aquifer, and to raise concerns and issues and identify problems and propose solutions. WERI is specifically designated in the MOU to be the repository for the data, to Since we already have the GHS database in place since 1998, we were well positioned to do that. And WERI is also specifically designated to perform technical studies or research, which we'll hear more about later. I'll cap this section off with a review and summary of the full integrated data collection system and what it'll look like under the One Guam framework agreed to in the MOU. The One Guam Water Resource Monitoring System will include both civilian and military data collection sites for groundwater data in the north, surface water data in the south, and rainfall across both the north and the south. First, I'll recap what MSERP is contributing to the north. That's the map that Miguel showed you earlier, showing the rehabilitated and the newly acquired wells that are going to be added. When MSERP is complete, MSERP is just in the north. When MSERP is complete, the whole system will look like this. So in the north is the same MSERP wells, the rehabilitation and the new material, and the stuff in the south. And since we built this presentation to support our engineering colleagues, I had to put at least one equation in it. So I'll summarize the program in equation form. The full-up One Guam Water Resource Monitoring System will be the sum of the current GovGuam funded CWMP with the rehabilitated wells from the first phase of MSERP, plus the new wells on DOD land that will be added during the second phase of MSERP, plus the assets that come with the Fenner Reservoir system. So it all goes into one package and one budget that the USGS prepares for the benefit of both the military and the civilian data collection for all three activities: rainfall, stream flow, and groundwater. So we'll turn from this map summarizing the system hardware for data collection to survey the mission of the One Guam Water Resources Information Program as agreed to in the 2016 MOU, and the services and products that WERI and USGS will deliver to meet the mission. So we'll start with the mission statement. Consistent with the MOU and in exactly 50 words, the mission of the One Guam Water Resources Information Program is to provide DOD and GWA with accessible and reliable data, timely analysis and reports, directed research on critical topics, expert assistance for informed engineering, management, and policy decisions, and professional education, technical training, and outreach support, all to best manage the drinking water resources of Guam. The management model for carrying out the mission is a hierarchy of activities that is best visualized as a pyramid. Data are successively acquired by the instruments, collected by the field teams, organized and interpreted in the databases and reports, and applied in research programs. The information products derived from the data on the other side of the pyramid is the shared information, and the information that's available to share starts with the raw data collected at the bottom, up through the conclusions and recommendations of advisory papers, technical reports, professional papers, research results. So the One Guam Water Resources Information Program, the OGRIP, is the whole pyramid, of which the monitoring system, which accounts for 2/3 of the budget, is the base, and the analytical program is the upper part. We're in USGS, work together and contribute and collaborate on each one of those. So I've already described the infrastructure and the data collection components in some detail. And in this section, I'm going to focus on what we get in return for the remaining third of our investment in the top 3 layers of the pyramid: the data management, analysis, reporting, and scientific investigations. The One Guam, let's see. WERI's contribution to the One Guam analytical program is the Guam Hydrologic Survey, or the GHS, Guam, which was launched by the 24th Legislature back in 1998. GHS already maintains a comprehensive database that I mentioned, which has been 20 years in the making now, and it contains more than 4,000 items, including historical data, such as drilling logs, downhole videos, as-builts, results of the original pump tests back in the 50s and 60s, and even copies of handwritten notes, along with links to decades of monthly and quarterly data on pumping rates and chloride concentrations. We get a monthly report from GWA that all goes into the database. The most visible GHS product is the Guam Hydrologic Survey website. And the guy who's responsible for that is Dr. Nate Habana, who's with me here today. Besides linking to the USGS database for the CWMP data, the website provides public access, school teachers, school students, to all of the maps, the technical reports, professional publications, the WERI scientific advisory papers, and all of our educational outreach materials. The lady who does our Water Kids program outreach, Kaylin Bautista, is with us here today too. She's also the lady that is overseeing the MSERP program for us. The database and website are among what I call WERI's 4 crown jewels. The other 2 are our aquifer map and our water quality laboratory. But the database and website are now investments of a couple of decades that are crucial assets to the professional community and everybody involved in water resource management. So moving up the pyramid to research, I've selected just a few showcase examples to share with you this morning. We at WERI are occasionally asked, so what kind of research do you do that's helpful to engineers and managers and others who need practical advice? And what exactly do you do with all that data that USGS collects from all of those wells? So here's my first example of what we do with the data we collect, how it helps those who produce, manage, and protect our water supply. And I've invited Miguel to jump in on any points that he'd like to add. This project was led by Dr. Habana, who coached a student who used the CWMP data collected by USGS from 2001 through 2016 at these 3 deep observation wells shown here in the core of the Jigo-Tumon Basin to determine the thickness of the lens and its response to changes in recharge. The left-hand side of the screen shows the structure of the transition zone at the bottom of the lens. And the time series at the bottom is the history of the lens at deep well EX7, the one that was relocated at Wettengell Junction. And the light blue layer is the freshwater lens. The first striking feature that you see here is that the lens is 100 to 125 feet thick here. And for comparison, the graphic shows a depth of a typical production well, 40 feet in that 100 to 125 foot layer. Studies like these provide us with solid information that we need in order to give you and the engineers high confidence advice for selecting well depths and pumping rates that will deliver both maximum efficiency and sustainable production. You don't want to induce saltwater intrusion by overpumping, but on the other hand, you don't want to let water go unused where you could pump more and reduce your efficiency or value added by underproducing and underpumping either. So it gets even more interesting. From 2000 to 2010, Mother Nature generously provided us with a remarkable natural experiment. The first 5 years on that time series are the second wettest on record, during which the lens thickened by 25 feet, which is 25%. And the following 5 years were the second driest on record, and the lens thinned by 25 feet. Note that since 2010, the lens has been thickening, which demonstrates the excellent storage capacity of this aquifer, what I like to call the reservoir effect. Like its surface counterparts, it fills quickly, but it drains slowly. So short bursts of wet weather recharge it, while it's relatively resistant to emptying during drought. You can even see the contribution of Tropical Storm Ting Ting in 2004 that dumped a huge amount of water in a single day, and it got it. If you were to design an aquifer, you could hardly do better. That's why I like to call this the world's best aquifer. Incidentally, the project won a national award for the Weary graduate student, Becca Dewar, at the, when she presented this project at the U.S. National Groundwater Association Conference in 2018. And she was also selected for having written the Outstanding Graduate Thesis of the Year by the UOG president. The next example of research, and another example of the value of good long-term records that I'd like to share, is based on data from GWA and GIPA. And it's also based on work done by Weary student research assistants, beginning when Dr. Habana was a student and continuing most recently with a bright undergraduate UOG chemistry major who worked for Dr. Habana this past year and is now on her way to medical school. The larger circles, the yellow and orange circles that you see, depict the locations of our production wells and the current concentrations and trends in the nitrate concentration. The smaller red dots on the map at the left show the locations of septic tanks. The data show that nitrate concentrations have been increasing in a substantial portion of our wells. Rising or abnormally high nitrate concentrations can be an indicator of associated but undetected presence of raw sewage contamination. So during this past year, our chemistry major, Ms. Jezrelyn Balaklek, compiled and analyzed trends on 146 wells from records over the past 3 years to over the past 3 to 4 decades. The first example shown here exhibits a continuous 35-year upward trend. The second climbed steadily for the first 15 years and then leveled off starting about year 2000, and it might have even slightly decreased over the past 2 decades. But about 60% of the wells, of those 146 wells, show one of these first 2 types of trends, in which concentrations increased over all or part of the record.
So I just want to point out at this point, Commissioner Sanchez might remember that we use this data, this type of data, to support our position, GWA's and CCU's position for good policy on aquifer protection and counter misinformation that was being provided by the real estate development community.
We're going to call John Wayne for this part.
Right. So, you know, it highlights the value of the type of work that Weary contributes and how we can use that to help us manage the aquifer, right?
And you know, just as an aside, I want to think about it. This is hope that we revisit, I briefly talked with Senator Perez, would you be interested in revisiting this issue? Because we almost got that bill passed in the last session. There appears to be, I thought there was some consensus achieved with the real estate community, and particularly John Duenas, because he has a lot of influence in how they look at the problem. And I thought we had reached some compromises. So, outside of this session, let's keep going. But if we could talk about that offline over the coming months, especially legislatures. Every day we get closer to the end of their term, that's a hit or miss opportunity sometimes. And if we could get that bill resurrected, and maybe before we do that, talk with John Duenas. Say, you still okay with this? And if you are, we do have a nitrate challenge, and let's see if we can mitigate it with the strategy that basically you two ended up developing. That was a more acceptable solution.
I think we can do that, and I think it's critical when we do that to also bring in Guam EPA, because they were a big component. Their regulations were a big component in what we needed to do to get everybody on the same page.
Right, and it shows the power of collaboration. Right. With that, what I'm most proud of is each year we sit with WERI in particular. We get this overview, and I was just on the radio. In fact, they were asking me. I was mentioning the collaborative effort between WERI, GWA, the military. That aquifer is, without that aquifer, we don't have Guam. And we all are working really hard to do everything we can to learn about it, take what we learn from our research and apply it to protect that aquifer. And this, Peter Roy, you're getting the summary of what's going on by a small group of professionals dedicated to protecting that aquifer, and so that we can always have drinking water. And that's why I apologize I'm late, but I always try never to miss this, because it's wonderful information and wonderful work, and I'm very grateful. Thank you, Dr. Jensen, and your team that's been with it a long time. Appreciate it, and you too, Miguel.
Thank you. So just one other thing I wanted to point out before we move into the next section. Dr. Jensen is going to go into a little bit of detail about modeling, and I wanted to re-emphasize and maybe remind the commissioners, on a day-to-day basis, our engineering department and our operations department uses models. We use the hydraulic model for both the water and the wastewater system to determine impacts for new connections, how we can improve our operations, where we might be seeing issues with either production or distribution issues. We use those models on a day-to-day basis, and they're critically important. So those models help us to manage our finished product, right? The water that we provide. But it's just as important, I think, for us to manage the raw resource. And so that's the modeling aspect that we don't have any input on right now, or we don't control, but we definitely need. And that's what Dr. Jensen's team does. So I just wanted to set that out as a lead into this discussion on the next few slides.
Thank you, Miguel. So as Miguel just explained, for the next showcase example, I'm going to describe our current and proposed modeling programs, both USGS and WERI. I'm going to start with a description of the previous WERI USGS modeling collaborations, and then describe the separate but complementary modeling programs, one of which we already have underway, and all of which we are proposing to continue under the One Guam framework of our analytical programs. I'm addressing this example in some detail now because it illustrates, as Miguel just mentioned, how we will meet the MOU mandate for WERI and USGS to specifically develop and maintain technical tools and provide technical studies to help solve water resource problems. It also shows the value added achieved by coordinated collaborative work. I previously highlighted the productivity of the USGS-WERI collaboration that developed the groundwater model funded by the Marine Corps back in 2010. And I'm going to now describe our follow-on collaborations of the past decade and our proposed plan for going forward with separate but complementary programs in support of the One Guam Water MOU's objectives, which, as you recall, is to maximize effectiveness of the current system and provide sustainable, reliable water delivery, which means developing a system to improve the capability as we go. So the 2010-2013 model was a model of the existing system, and we applied it to evaluate the limits for meeting additional demand by additional pumping and the potential effects of droughts on the water extracted by the existing system. It indicated that increased groundwater withdrawals of the amounts expected from the buildup could result in increased salinity of pumped water in certain areas, and that such responses would be substantially worsened by droughts of historical duration and severity, such as the 97-98 El Nino drought. So in September 2013, on the day after Steve Gingrich from USGS briefed the results here on Guam, I got an email from one of the prominent engineers at one of the leading firms that services both GWA and WERI, who essentially asked me, okay, so yesterday you guys showed us how the existing system will respond to increased production and drought stress, and it indicates we could have some problems. But what if we improve the system? How much water does the aquifer actually have that we could extract with a better, or perhaps the best possible system? So answering this question called for a different kind of model. Those are the model results in the slide there. This called for a hypothetical model of a possibly very different future system, an ideal system that could tap the theoretical maximum capacity of the aquifer. So I called Steve the next day and suggested that although the 2013 model was structured for the actual system, we might be able to jawbone it sufficiently to accommodate the proposed or conjectural systems that could offer reliable answers to this question, and that if he was available to join us, our Guam Hydrologic Survey Program, a locally funded program, could fund a follow-on collaborative project to reconfigure the 2013 model for some exploratory scenarios. After building a $1.2 million model, we had a powerful tool at our disposal, and we'd be ashamed to shelve it. There was a lot more we could do with it, even if we had improvised a bit with it. It's like investing in a big new freight liner. You don't just haul a few loads with it and park it and then walk away. You want to keep it on the road for as long as you can make money with it. So Dr. Habana had just finished his PhD and was about to join the faculty at WERI. So we had a new driver. We put it back in service.
A young driver.
A young driver. Trucking is a young man's occupation. We put it back on the road with a mission to haul a new kind of load, specifically how much water of acceptable salinity or better could be withdrawn if all the island's existing water production wells, which are currently spread across the aquifer, the upper left, were to be replaced by the same number of new wells. In other words, you shut them all down and you drill the same number of new wells in the richest zone of the aquifer, which is shown on the other map. It's the ideal system. And this project kept us busy from 2014 through 2017. The result, and the answer to our engineer colleague's question, is that if ideal placement of these wells were possible, total production could be probably doubled from 40 million gallons a day to 80 million gallons a day without exceeding the design limits for salinity. Now, are we going to ever actually do that? Probably not, but it gives the managers and policymakers an idea of what the upper limit is that Mother Nature imposed on us and how much space we have to develop the aquifer, given the economics of it and the technologies that are available. So the 2014-2017 project was followed by another project, a 2-year project, in which this young man, Mr. Daniel Superalis, completed his master's thesis under Dr. Havana's advisement and published a weary technical report using this model of the ideal system to evaluate basin by basin the volumes of water that could be produced well by well in the ideal system before salinity rises above the red line set by US EPA guidelines. So we now have a resource for the first time of reliable, empirically based estimates of the ultimate natural capacity of the aquifer, basin by basin, for producing water and keeping the salinity inside regulatory limits. So we have parameters that the engineers can use, policymakers, the planners, the managers. And we can give you an answer that's something other than just a wild guess. So we kept the 2010 Freightliner on the road until 2019, and it served us well. But it's got a lot of miles on it now, and modeling technology has advanced a bit in the past decade. And as I already noted, the 2010-2013 model wasn't built for exploratory modeling. So it's time for a new model. Get it? New model? Or more precisely, for complementary and parallel but independent USGS and WERI modeling programs in which USGS will provide a permanent state-of-the-art model of the actual system installed across the entire aquifer, and WERI will provide high-resolution models of each basin with the flexibility to explore fundamental modifications and potential major realignments of the well fields. It's like having a trucking company with 2 divisions, one with a heavy long-haul rig and another with a fleet of lighter trucks that can go places and haul loads that the big rig is not designed for. So you have independent but complementary missions serving the same customers who need the products of both. So I'll now describe the road ahead, how we propose to equip One Guam managers, planners, and design engineers with a combination of modeling tools to maximize the effectiveness of the existing system, that's the USGS model, across the entire aquifer, while also reliably evaluating alternative development strategies basin by basin to provide the second objective of the One Guam MOU, sustainable, reliable water delivery indefinitely. I think you can already see where I'm headed with this. So the centerpiece of the USGS analytical program will be acquiring and running the next big rig. Building on the 2010-2013 project, they will construct and maintain a new, current state-of-the-art model for estimating how the existing system across the entire aquifer may respond to changes in pumping and recharge. Same objective as the 2010-2013 model, only with an updated model. So managers considering, for instance, how to keep up with the increasing demand or with the current system in place, and how to improve water quality, can get answers to questions such as how much the salinity might increase or decrease in an existing well field or an adjacent well field if the pumping rates in all or some of the wells were increased to meet demand or decreased to improve water quality by different amounts, and how much salinity might increase or decrease across the entire aquifer during an unanticipated drought. Aquifer models like these have become the standard management tools across the entire water provisioning industry. And USGS models are the industry standard. Now, Like any big truck or other complex machine, the groundwater model requires scheduled maintenance, including a top-to-bottom overhaul every 3 to 5 years. So you can keep it on the road and make a return on it till it's obsolete. The USGS modeling team will update this model every 5 years, not only to incorporate installations and closures of production wells by GWA and NAVFAC utilities, or changes in pumping rates, or if we get more and better data on rainfall and recharge. It'll also enable them to stay abreast of the rapidly evolving modeling technology. And when the time comes, it is now, they'll retire the old model and invest in a new one. An essential part of these 5-year overhauls for the USGS program will be construction of precise and accurate water table maps, one at the end of the dry season, one at the end of the wet season, from simultaneous measurements in all 24 observation wells for 7 consecutive days. So this requires lots of instrumentation and round-the-clock coordination, the field teams, trained technicians, and you'll see this in the budget as a spike in the USGS and the analytical budget every 5th year. But it's worth the investment because accurate water table maps are, first of all, indispensable for calibrating the groundwater models. It's like setting the specs on a diesel engine. When you overhaul the model, you have to see, does it match reality? Does it predict the water levels that are actually there using the rainfall you're putting into it, for instance? So, moreover, the maps of the water table are the fundamental tool for hydrologists everywhere. It's the fundamental tool for estimating the flow directions for groundwater and the flow directions for contaminants that they're carrying. So you can see who lives downstream from where the contaminant enters the system when that becomes an issue. And then finally, I'm speaking for USGS now. Todd Presley is tuned into the meeting here, but obviously they can't be here in person with us today. But they will continue the services they provide to the Navy for the FENA watershed modeling and reservoir assessments. So let's talk about the WERI program, the short haul fleet. Our modeling program will focus on smaller patches of real estate, specifically on each of the 6 basins one at a time, so that you can achieve the flexibility that you get with finer resolution, which you can apply to a smaller piece of ground. This will enable us to explore options for a single basin where you want to model only that basin. You don't want to model the whole aquifer just to see what's going on in a single basin. It's like using a lighter weight truck that can go into and turn around in places where you can't take the big rig. Or where if you took the big rig, it would take forever and you'd waste a lot of gas and a lot of time and probably get stuck with it. So you can do it more quickly and with less fuel. So this will build on our previous exploratory modeling to explore where and how the aquifer might best be developed or redeveloped to realize natural efficiencies by measures such as moving production wells into the richest areas, like Miguel mentioned, and conversely, what parts of the aquifer you ought to stay out of. And since 2019, Dr. Urban has had a student, and he's forging a collaboration to develop a high-resolution groundwater model of the Jigo-Tumon Basin, which is the obvious first one to start with because it's the largest and most productive. It's also the most well-developed, the most populated, and the most threatened. But ironically, probably has some of the largest remaining reserve of the Aquifer 6 basins. Our first application of the model is to scenarios suggested by GWA's chief engineer to test the merits of permanently relocating certain production wells and predicting performance at different depths and pumping rates. This is a thesis project for Mr. Thomas Guilo is another one of our brilliant research assistants being advised by Dr. Havana. With the support of the GHS program, WERI will eventually model these other basins, and these will be standing tools for strategic planning as GWA and NAFAC-MAR go forward with aquifer development. And finally, I'd like to mention that the higher resolution afforded by these smaller scale models facilitates innovations in modeling itself, such as this new technique depicted here, developed by Dr. Havana to incorporate Bedos flow into karst aquifer models. So this is cutting-edge scientific research, and we are optimistic that we're going to be able to incorporate the effects of faults, fractures, and conduits, which capture the flow in the aquifer in important ways. So, to sum up, USGS will maintain the One Guam Fleet's big rig with the long-haul aquifer management mission, and WERI will maintain the shorter-haul fast turnaround squadron for the aquifer development and model improvement missions. I'd like to conclude this part of the presentation with the observation that the program we're proposing, all of the One Guam Water Resource Information Program, not just the modeling, is not merely an expense, but an investment that preserves and expands capacity and promotes sustainable management. And I'd also like to point out that WERI and USGS will leverage the OGRIP funds with the resources that we get from other agencies, NOAA, NASA, US EPA, NSF, even other DoD programs. Finally, I'd like to highlight that this is an investment in our local professional workforce. Students working on these kind of projects study local problems and then enter the local professional workforce already equipped to address them. And it's important to note that training new scientists and engineers is one of our national mandates for the funding we receive from USGS. So it was from both enlightened self-interest and our obligation to our funding agencies that WERI faculty back in 1994 put together the Graduate Environmental Science Program, and that we've graduated about 2/3 of the more than 60 students who have finished it since then. The pre-engineering program from which our School of Engineering evolved was pioneered by two members of the WERI faculty, Dr. Kay and Dr. Heitz, who is now the founding dean of the engineering school. And recently, WERI has played a big role in launching the four-year engineering school by staffing the committees that recruited its faculty, helping prepare its curriculum, forging partnerships, and sponsoring collaborative research.
I wanted to just also make the point that the commissioners may recall previously in the I've mentioned one of our long-term strategies at GWA is incorporating more engineers into our operations, the operational divisions here. And we've already had discussions with UOG about a cooperative education program with the College of Engineering so that their engineering students can come work at GWA for a term, earn credit for their degree, get paid, and then also provides them with experience that they can use to get Guam EPA certification as operators within either the water production system or in our water distribution and treatment systems. And then, once they graduate, perhaps seek permanent employment here and enter our workforce as operations engineers. I will tell you that in the time that I've been here, some of the most brilliant engineers that I've met that are helping us to build these new treatment plants and to do the work that we do are engineers with operational experience. These are the guys that understand what it takes to run our systems and the concerns that should go into the design and construction aspects of these new systems so that it makes it easier for our operators to run. Right? And so that type of collaboration and integration is another benefit and that serves as an investment in GWA and its workforce.
Thanks, Miguel. So here's our weary brag wall with about 25 or thereabouts alumni and students who live and work on Guam. And I just realized that all three of these people sitting back here with us are on that drag wall. So,
Can you just introduce them?
Oh, yeah. Commissioner Martinez is a new member
yes,
and does not know Dr. Hamilton, so maybe you could introduce them.
right. Well, Dr. Vanna was one of our students that we discovered back, when did you come on with Dr. Heights? About 1998?
I remember,
98.
yeah,
A lot of good things happened in 1998.
yeah.
So he finished his master's in 2009.
2009.
Dr. Heights was his original advisor. When Dr. Heights retired, he handed Nate off to me, and I handed him off to the PhD program at Mapua Institute of Technology. He graduated in 2014, and we snatched him up on the faculty in 2015, and he's hasn't lost the momentum that he's had since 1998. Kalen Bautista.
Before you move on, Doc, Commissioner Martinez, I just wanted to tell you that I came on board of the CCU in 2009. 2010, he produced a model that showed us how to go into the aquifer. And I was very impressed at that time. They said, wow. Because, you know, we talk about the aquifer, and we talk about everything, but he actually produced a model that would show us, if you went in the aquifer, what the different basins were like. That the basin that's very rich has a basalt rock base to it. That's the richest part of the basin. Then you have the saltwater basin. So I was very impressed. Glad to see you're staying with us. Good things continue to happen. And I'm glad we're supporting you with the engineering school too, because that's an important part. Continue.
Thank you. Yeah, just keeps getting better. So, Kaylin came on board. She's a UOG biology major
Yeah.
who
Buenas.
started out in the program. And when did you start, Kaylin?
2009, took a break, got married, came back in 2013.
Right.
Yeah, she came back. She majored in biology.
Marriage will do that to you.
Yeah.
We have three tracks in the environmental science program. There's economics management, there's biology ecology, and there's geoscience engineering. Kaylin was a biology major, a very good one at UOG. And like she said, she came into the program, took a few courses, got started, and then took some time off. Came back to me one day and said, I want to get into hydrogeology and do a thesis in hydrogeology. I said, but you're a biology major. And she said, right, I want to do a thesis in hydrogeology. So she aced the course.
Well, most importantly, they're the two youngest people in the room. So we know this will continue as long as we keep the rigs on the road.
Yeah. Well, yesterday they were running a program over in UOG in the big room 129 in the business building. For what you have about 60 or 80 teachers, or 100 teachers there. 40.
Wow.
Sure was a lot. And Dr. Vanna gave him the aquifer tour. Good thing about that virtual tour is it survived the past 2 years that we had to shut down the real tour.
Yeah.
So he's kept us on the road in another way too. So anyway, Kaylin did a thesis in hydrogeology studying this is pure science, studying the process of percolation, how the water gets through the aquifer by spending 2 days a month hiking out to a cave or a Artesian and collecting drip water off the stalactites, dripping off the ceiling. And she did that she did the research assistantship for, about 4 years? And led the field team. And she's another that finished her thesis with award from the President's Office for the outstanding graduate thesis of the year. So
More fun than biology?
Yes.
There you go.
yeah. And I'm saving Tom Cruise here for the next brag wall, which is featuring our contribution to the GWA workforce. Tom was one of our first to go through the pre-engineering program. Dr. K still brags about me. And he's, well, I'll let his boss brag about it.
So, the three GWA employees that are on this screen, Dr. Jensen wanted to highlight as, again, an example, a hard example of the collaboration and the benefit to GWA of this relationship that we have. So Tom, as you know, has been our chief engineer for many years. He's done a great job advancing our CIP program. And in discussing the future of GWA and the strategy for getting more engineers involved in operations, Tom helped me establish that by assigning one of our newer hires directly to operations. So he's an engineer, but he's assigned to operations, and we're expanding that. But then when the position for the AGM of operations came up, Tom stepped up and is now leading that charge of integrating engineering into operations. So that's helping me achieve what we hope to be a long-term strategy for GWA to improve. On the wastewater side, you all know Mo McDonald, another graduate from Dr. J's program. She leads, currently she's senior engineering supervisor with us and leads our wastewater CIP. And then, of course, our recent replacement for our utility laboratory administrator, Jennifer Cruz, who unfortunately, Dr. Jensen always gives me crap about because we pilfered her from Wary's lab.
We stole the clearance for
So we did steal her away, and she's doing excellent work for us to keep our lab going with Mr. Kemp. And so these are just examples of that collaborative relationship and the benefit to GWA. So we wanted to point that out.
Yeah, I'd like to also point out that Mo Kingham McDonald was one of the other good things that happened in 1998. She was one of the first beneficiaries of the Guam Hydrologic Survey funding that funds our graduate research assistantships. And in fact, I had just put out the advertisements for them a couple of days before, and she showed up at Weary one morning and said, Dr. Jensen, I want to join your program, and I've applied for a research assistantship. And I said, but you already have a full-time job with Guam EPA. And she said, yeah, but I want to be a full-time student, and I want to get this degree. And I said, how are you going to do that with a full-time job? And she said, I'm going to quit and be a full-time student. And I said, okay. So she did a study on the relationship between increasing salinity in the production wells, every production well in the aquifer, and they haven't changed in the past 20 years that much, and the relationship to the engineering and construction and operational components. In other words, how deep it's set, how hard it's pumped. And that technical report is still the basic manual on the relationship between the well construction and operation and the salinity performance. And she produced another technical report doing part of our database on the nitrate in the aquifer, which is part of the early work, and now she's the wastewater, what's her title again?
Senior Engineer Supervisor for Wastewater CIP.
Yeah, and then Jennifer Cruz, as Miguel mentioned, you know, we consider her sort of double alumni in that, you know, we recognize not only do we produce graduate students, but the people that go through our lab are mid-career people who do very well, and you know, because of her success, she was snatched up for a promotion. I certainly couldn't deny her that, but she spent 10 years gaining experience in our laboratory, and that's another contribution that we can make. And those laboratories work together. Actually, the GWA laboratory is our, I think, our biggest customer for our laboratory. Do you want to say anything more? Okay, yeah, it's time to move on. So, we'll conclude this presentation then by examining how the One Guam program is going to be structured, administered, and funded. And these are topics for managers, so I'm going to hand the rest of the presentation to the GWA General Manager.
Okay. So we spent a lot of time setting up what the program is, how it's structured, how it functions, and now it's time to get to the discussion on how it's going to be funded.
On money.
Sorry?
On money.
On money, yes, sir. So the OGRIP budget has two parts, one for the data collection program and one for the analytical program. For the data collection program, costs are assessed for servicing and collecting data from the instruments at each station in the network. On the map that Dr. Jensen showed you with everything island-wide, all of those, whether they're on GWA property or DoD property. So the maintenance of the service roads, the supporting infrastructure, and all of the data collection stations will be the responsibility of the landowner. So either GWA, GovGuam, or DoD. So that means site security, scheduled maintenance, repair, and rehabilitation of the facility come from the landowner's budget and not the OGRIP budget. The three kinds of stations that are in the network, and each is a separate line item in the budget, are the rain gauges, which Dr. Jensen described, the stream gauges and the Fenna stage on DoD property, and then the 24 aquifer observation wells, 14 of which are for salinity profiling. The costs for the integrated analytical programs are mainly the labor and material costs for the scientists, technical staff, interns, and student research assistants. The WERI GHS budget includes salary for staff and student positions dedicated exclusively to OGRIP to perform database management, statistical analysis, website maintenance, and preparation of routine reports to meet the OGRIP mission. The budgets for training and outreach projects are contained in the analytical programs budget, and the research projects, which occupy the top portion of the pyramid, are also part of that budget. So the total budget and cost shares for 2022 through 2027 is broken down here between DoD and GWA. So the green bars are the GWA GovGuam costs, and the blue bars are the DoD share, and the gray bars are the total. And just to give you an idea, over that period, the average is about $1.3 million a year, and the split for GovGuam GWA is $760,000, or about 57%, and about $571,000 for DoD, or 43%. During the 2020, the data collection equipment will be acquired and installed, and the data collection network will be fully operational beginning in 2023. And the budget will be concentrated on data collection and analysis, and you can see that in the 2023 spike in the numbers there. For the groundwater costs, this slide demonstrates the proposed cost sharing between DoD and GovGuam for the groundwater data collection. Costs of the data collection are divided according to the permitted groundwater production rates in each of the 6 basins. So overall, the gross split for the first 6 years shown on the graph is about 71% for us and 29% for DOD. And just to give you an indication, there are 24 observation wells in those aquifer basins, and the dotted lines separate the basins of the aquifer. So you can see where the most green dots are is where there are the most production wells, and that's the Jigo Tumon Trough. And in that basin, GWA accounts for about 85% of the permitted production, and DOD only 15%. Conversely, in the Agafagumas and the Anderson basins, Agafagumas rather, GWA only accounts for 24.8%, and DOD accounts for 75% of the permitted production capacity. So that's how, based on those percentages and your permitted production capacity between each party, that's the scheme by which we agreed with DOD to share the cost for the groundwater data collection. All analytical costs will be split evenly as noted previously, and the landowner is separately responsible for maintenance of the facilities, service roads in each of those data collection stations. And you know, as the slides that I presented earlier on the before and after show, the regular maintenance and upkeep of that is critically important, right? We don't want to repeat the mistakes of the past and wait 20 years, let it all deteriorate. We're done with that model. As you know, we're moving forward with a more asset management intensive approach, and this corresponds with that.
And let's be clear, Miguel, when you say the GWA GovGuam, it's the GWA budget that you're talking about.
That's what we'd like to propose, sir, yes.
It's our funding, yes, because it's us.
So, this is for the data collection costs. This provides a breakdown within our share of what those costs are. And as you can see from the pie chart year over year, from the bar chart year over year, but reflected in the pie chart, the overall averages, about 70% of the data collection costs are directly associated with the groundwater component. 16% of the costs are attributable to surface water data collection for Ugam and the Lasafua stream gauges, and 14% are for rainfall data at various stations from Umatic to Mount Santa Rosa. So this slide shows the breakdown of our budget between the data collection and analytical components. And as we mentioned, the analytical components are split 50-50 between DOD and GWA. But they do change year over year, and this shows for the data collection, as Dr. Jensen previously mentioned, it's the largest component, 66% roughly, and 34% for the analytical studies. And you'll notice again on 2023, the spike in the 2023 budget for the analytical program is associated with the calibration of the new groundwater model for USGS, and that begins that 5-year cycle of updating it every 5 years. So that'll start in 2023. So this sketch kind of shows the general funding flow and structure in which WIRI will provide, as it does now, for the existing civilian GovGuam programs, central administrative support. As we've previously noted, WIRI has received and administered the funds for the Comprehensive Water Monitoring Program and the Guam Hydrological Survey from the Guam Legislature since 1998. Local and federal funding for the program are coordinated with USGS through a joint funding agreement. WIRI has also received and managed funds for the GHS and already has in place the administrative staff, resources, experience, and procedures to provide unified and centralized management with accessibility, visibility, and accountability for the integrated One Guam component programs. We do point out that you'll note two different MOAs or separate MOAs will be required between DOD and GWA for the funding of the OGRIP, as well as with WIRI and USGS as the service providers. So in a nutshell, this next slide sort of summarizes the products and services that we've been talking about, the products and deliverables that we will obtain from OGRIP. At the center, circle in this slide, and they're color-coded to match the segments of the Water Resource Information Program pyramid that Dr. Jensen broke down for you earlier. The circular quadrants outside of the center, in green and in orange there, indicate the priorities for both the CCU and GWA that are best served by scientific guidance provided by these products and deliverables. Outside of each quadrant are specific examples of these products and deliverables which are critical to the accomplishment of our CCU and GWA priorities. And the example I gave earlier, Commissioner Sanchez, about the policy decisions that we make with regard to legislation that's proposed and so on and so forth, that type of expert advice on aquifer protection, resource policy consultation, those are at the top end, that applied research of that pyramid, right? The public education part is also important to the CCU, and that's part of the technical tools and modeling portion of the pyramid. For our purposes, as I mentioned previously, we have, and as Dr. Jensen talked about with the modeling, realigning production facilities to best suit where the highest subbasins are, right? That's a tool, the production well siting and design, that's expert support and directed research, right? And then the aquifer map and model are technical tools that are provided by OGRIP, which help us in our CIP and engineering support functions. He talked also about not overpumping and not underpumping, and those are operational, managing the operations issues. That's a priority for us, and that type of expert advice and consultation is another product and deliverable which directly benefits GWA. The sustainable yield assessment as a product of expert support and applied research. The salinity trends and modeling tasks, specifically directed modeling tasks that we've requested, for example, are the technical tools and modeling components of that pyramid which provide a direct benefit to GWA in managing our operations. So, this slide is intended just to remind you how important the relationship is and the benefit that GWA obtains from the tools, the research, the data, that is all part of this One Guam Water Resource Information Program. And I'd just like to round that out by saying that I'm presenting to you here what our collective priorities are, but the aquifer doesn't care who's pumping from it, whether it's DOD or whether it's us, and they don't care the aquifer doesn't care who's contaminating it, right? And these are all issues that are related to managing that sole source aquifer that we all need to pay attention to, and I think the Commission will agree that it doesn't make sense for us to have our own separate program and for DOD to have their own separate program, because all of our activities affect the same aquifer, and what we do affects them and what they do affects us. And that's another good reason for us to support this One Guam Water Resource Information Program. So just to conclude, returning to the objectives of that 2016 One Guam MOU and the OGRIP mission statement. The infrastructure, the organizational structure, the activities and programs, and supporting budgets that we've just now examined will put in place a One Guam Water Resources Information Program that meets the vision and commitments of the MOU and provides the products and services listed here to ensure the most effective management possible for all of the island's freshwater resources. So with that, we'd be happy to answer any questions you might have. I know we inundated you with a lot of data, a lot of information, but we're happy to answer any questions you might have.
I just want to say I've had the benefit and the luxury of being around the longest with this effort, and to see where we were in January of 2003, the first MOU in 2010, the amended MOU that we executed in 2016.
Yeah.
You folks are the unsung heroes of protecting that aquifer, and you've paraphrased what I used to always say, that there's no fence lines in the aquifer, and all our straws are in that same aquifer. And to see the goals of a shared collaborative effort to protect that aquifer, and how far we've come, and how much work continues. This work will never end. We can never stop watching that aquifer. And Dr. Jensen's put it so well, we have this gift that's been given to us, And even with a lot of rain, or even sometimes when we don't have rain, that aquifer continues to be able to support our needs. And it's really, I'm very proud and very happy to see how far we've come and how well it's matured into something that we can sustain. And to the degree we can support it, the financial effort, with all the monies that we do have from ratepayers at GWA, this is an investment in the future of making sure we always are able to ensure that there's enough freshwater sources for our community to access responsibly and carefully without threatening its future. And you know, I applaud all of you, and particularly you, Dr. Jensen. There are icons in all sorts of endeavors, and you're one of the water icons, and you succeeded a famous water icon. I think Dr. Mink and others, and then you've taken it to the next level, and now with the technology that's available, we continue to be able to find out more and more about how our aquifer works. We continue, and we'll continue to need to invest in sustaining that availability of information and refining and taking advantage of the technologies that will emerge from these younger people to protect the most valuable. Well, I guess it's a tie between the ocean and the aquifer. I kind of go back and forth, but they both have water in it. And there's a point where salinity, we want on one part of the water, but not on the other part of the water. And it's a constant effort to manage. And we're very blessed to have UOG, WERI, and GWA, and the military working on this. There's been no hesitation to work on this together. And you've just summarized the successes so far, the challenges that remain, and your roadmap to meet those challenges and to sustain our successes. And it's probably one of the best investments that Miguel will ask us. Like, budget time is coming up, but it's one of the best investments we can make to ensure that our people have access to safe drinking water and its source of, I know we treat it with the chemicals, but if we don't have it to treat, if we don't have the water in the aquifer, we don't have it in that natural reservoir that God's given to us, then Guam won't be Guam. And in many ways, your efforts are keeping Guam and allowing Guam to be the good place that it's always been and can continue to be. So I'm very grateful for your work, and I applaud you, and look forward to supporting you guys and your continued effort. Thank you.
I think, go ahead, Commissioner Martinez. No, go ahead.
I also want to share those wonderful comments with Simon, but for me, really, it's the partnership. I really recognize this type of partnership between the university, WERI, DOD, and the Guam Water Works. This is the type of work that we should be working for, really. And water is very important in our resources. But I'm excited about it. I like it, and I also want to thank the alumni. I was at the university for many years. I've worked with alumni. But when I saw those presentations and the work that's being done by Dr. Jensen and the alumni with their master's degree, and finding the work and continue to help Guam, just makes me proud about the whole concept that we're doing here. So with that, I just want to say thank you, Dr. Dr. Jensen with the WERI, the University of Guam, Miguel, and the military, DOD, for making this a better place and a safer water resources.
Thank you, sir.
Yeah, I think, Miguel, I've been always pushing you in terms of making these improvements that we have to make in our system. And one of the things that happened was when the CCU came into existence, that was a crucial, threshold moment for GWA, but more importantly for the island as a whole. Water and power, but water most especially is crucial for life on this island. And I've always pushed the point that in terms of being essential and critical. GWA and GPA are the critical, essential parts of this community. Without those two, you don't have a community. You won't have a hospital. Believe me, you won't have anything. You won't have education, because nothing will survive. You know, you can't go back to the Stone Ages where we're doing laundry in the rivers and trying to find fresh water somewhere. So we've come a long way, and one of the things that I particularly am hopeful of is we, back in the 90s, were able to get the power system kind of like going in the direction of becoming one power system. And this is what I'm pushing for with regards to the water system and wastewater system. We really need to take the island as one entity. I like the partnership we've developed with DOD. I'm hoping that someday in the future we'll be able to prove ourselves and make them understand that we should do the water and wastewater business on this island. This is really what we should do. Taking the politics out of it. We're professionals. We do what we need to do, and we do what we need to do for the future generations. This is not just what we're doing here today. It's not what we need to do for us today. All that we're doing is really for the future. It's not for us today. It's for our grandchildren and great-grandchildren. Because if we don't do this now, we're not going to leave them a very good world. So thank you very much for your efforts. And I think you'll have the support of the Commission in terms of what we want to do in terms of funding for this program. Okay? It's something we have to fund. It's not something that we should. It's something we have to, in my opinion. Okay?
Thank you, sir.
So thank you very much. Okay?
I like calling him Dr. Weary.
Dr. Weary. No, you know, Dr. Jensen, Dr. Jensen, one of the things that I've always enjoyed is I've gone on several tours with you, you know, looking at the island and geology, and I never really understood most of it, and I got a better appreciation of it, and it's a tribute really to the fact that we have good people such as yourself who then develop other good people. And these good people will be developing other good people. And you know, we mentioned that, I'd like to talk about that for a minute, because I have to tell you, when I joined the CCU in 2009, I went everywhere. I wanted to see all the facilities. And I saw the lab that, what's her name? Conchita. Who retired? What was her name? Carmen, right. So I went up and saw Carmen at the lab at the old Lane International building. I don't know if anybody ever really remembers that. I remember that. I'm that old. But there was Lane International. Pete, do you remember? Peter? And that's where our lab was. And I looked around, I said, oh my God, we have to do something about this. And we have. We have now a brand new lab. So when we stole Jennifer, at least we put her in an upgraded lab, you know?
At no expense to you.
At no expense to you. But you know, Simon, you just reminded me something, Commissioner Sanchez. We do this with the ratepayers' money. And believe me, we all want to be judicious in the way we spend our ratepayers' money. And when we see results like this, that's when we can turn to the ratepayers and say, no, we put our hand in your pocket and we took money out of your pocket, and you are fathers and mothers, some of you are brothers and sisters, some of you are our children, our nieces, our nephews. Guess what? We didn't do it just for the heck of it. We did it because we're trying to make a better system, and that's the legacy that we're leaving. So you will have my full support for your funding needs. Thank you.
I should mention that Wary is going to get a new building
Oh,
funded by the Economic Development Agency. Came out of the Strategic Planning Initiative, first President Underwood and then President Price. Long story short, our executive director for the Research Corporation of the University of Guam, Cafe Morley, suggested we apply for a grant, and we did, and we got it. We've got to come up with 20% matching, and we're proposing to pay that out of our lab revenues. lab is going to expand. Amongst Dr. Van's other talents is he drew up the plans for the new building. And the university is going to be putting out the RFP for the architectural design here in a few weeks. And we'll double our space of our lab, and we're putting together a plan now to increase the services and increase the volume, and we're working on increasing the rent. So that's another good thing that's happening at UNG.
I applaud those efforts, Dr. Johnson, and you know, the one caution I always have in the back of my mind is, there's 2 points I'd like to make. One is, we do a great job of building things. Our problem is in maintaining those things. And that's what began this presentation, when we looked at those wells that we had to rehabilitate. We had let them fall into such disrepair. And that can't happen, and that's what I agree. We have to continually maintain our facilities. The second thing I'd like to tell you is, you know, I try and do a lot of reading just to better improve my brain, because it's not that good a brain. It has a lot of work to do still. But one of the things I read once is President Eisenhower, when he was General Eisenhower, and they're talking about all the plans of invasion and Normandy and all that, he said, plans don't mean anything. It's the planning process. So what we have here is not just one plan. This is a planning process that never ends. That's the whole point. You don't ever stop planning. You know, I mean, and sadly to say, in our history here on Guam, I can tell you that I've been aware of, I don't know how many land use plans we've had that have been developed and put on the shelf, and then they go away. And there's the key that I think we finally got around to is, you're continually planning. You don't stop. You don't say, here's the plan and this is it, we're done. It's a continuous process. So thank you very much for all your efforts. I look forward to a lot of challenges. Like I said, Dr. Banner, I was amazed when you did that in 2010. I sat back and go, wow.
Wait till you see the new one.
Yes, I'm looking forward to it. Okay, thank you very much. Any further questions? No? Motion to adjourn this work session?
Move. Second.
Okay. We're adjourned. Thank you very much.
Thank you.
Good job, guys.